Okay, this is term 3, week 6, I think, Math CA. It's a bit tricky, to be honest. It's not that easy for people who are new to the topic, or maybe just me because I was absent. But it's all new. Okay. Before starting, okay, I'm gonna try explaining the hold up, the new thing. Okay, the new thing is determining the sign of a quadratic. Okay, let's say, and I give you any quadratic. Let's say x squared. Well, why can't I write x squared plus 7x plus 12. Okay, and I told you greater than or equal to 0. Let's just, actually, no, let's keep it greater than 0. Okay, I'm gonna tell you solve this. So obviously, since it's a quadratic, usually it's gonna have two solutions. Yeah. For the way you're gonna do it, always you're gonna factor it. Okay, you're gonna find your two roots. If you factor this, you're gonna get x plus 4, x plus 3, right? Greater than 0. Okay, this is the way our teacher taught us. I'm aware that some people might have learned a different way, but this is the way she taught us. Okay, so what you're going to do is you're going to take your three roots. Okay, if my solutions are 4 and 3, plus 4 plus 3, that means my root is going to be negative 4 and negative 3, right? So when x equals negative 4, our equation equals 0, and when x equals negative 3, our equation equals 0. This is how she writes it. Okay, what does this mean? Why when x equals negative 3 it equals 0? Because it's a root. That means if you plug in negative 4, you're going to get 0. Negative 4 plus 4 gets 0. Negative 3 plus 3 gets 0. This is the basic quadratic stuff. So you find your two solutions, negative 3, negative 4. You write it in a table like this. Okay, now we're going to take a look at the signs. When x equals negative 3, we said y is going to be 0. And when x equals negative 4, y equals 0. Okay, what are you going to do from here? Okay, in between my two roots, the sign is always opposite to my quadratic. In this case, it's positive, right? So in between negative 3 and negative 4, what's opposite of positive? Negative. Okay, how about after my roots? After, it's normal, okay? So if it's positive here, then after the root is going to be positive, and before the root is also going to be positive. It only changes when it comes in between the roots. Why? Let me show you. For example, I have this quadratic here. Okay, I'll draw it in blue. Okay, comes down like this. So y would be positive all the way over here, right? Until it reaches down here, when it equals 0, the first turning point, right? Let's call this negative 2, and here 3. Okay, it reaches the first turning point, and all of a sudden it becomes negative. Y is negative, right? Then again it starts going up, but it's still negative, right? It's still negative, okay, until it reaches the other root. So that's why in between the roots the sign is always positive to the quadratic. That's just explaining why. Okay, so now can I solve? When is it greater than 0? Greater than 0 means positive, صح? So when is my quadratic positive? My quadratic is positive for everything before negative 3, right? So when x is less than negative 3. Also, it's positive for everything after. Oh, wait, I drew it wrong. Negative 4 should be here, negative 3 should be here, because it's negatives, you're going to the left. Okay, so everything before negative 4, so anything less than negative 4, and anything after negative 3, right? Just be careful on how you write the numbers. Okay, so this would be my two solutions when x is less than negative 4 and x greater than negative 3. So كل هالحكي على الفاضي. Let's actually solve questions now. Okay, I'm gonna screen write so the PDF. Which of the following is true about this quadratic? Okay, when is it greater than 0? Okay, first let's see what are our two roots, right? Let's see it. What are our two roots? Our two roots are 4 and negative 2 over 3, right? Because if you take equal to 0, negative 2, then divide by 3, negative 2 over 3. So those are our two roots. Let's write it. Negative 2 over 3, 4, equals 0, equals 0. Okay, and I know it's not fully expanded, but since there's no negative x here, that means the sign of the quadratic is positive. Okay, so what's going to be in between the roots? It's always opposite. So what's opposite of positive is going to be negative. Okay, How about what's after the roots? It continues as normal, since positive and here positive. Okay, so now we can solve. When is it greater than 0? Greater than 0 means it's positive, right? It's greater than 0 for all x before negative 2 over 3 and all x after 4. Let's see. All x before negative 2 over 3, is it positive? Yes. How about after 4? Is it positive? Yes. So we tick this. It is less than 0 for all real numbers x. Less than 0, that means negative. So is it negative for all of the numbers? Of course not, right? It's only negative in between these two. It's greater than 0 for all x such that x is in between negative 2 over 3 and 4. Let's see, between negative 2 over 3 and 4, is that greater than 0? No, it's actually less than 0. It's negative. It's not positive. Greater than 0 means positive. So obviously, this one will be wrong. It's less than 0 for all x in between negative 2 over 3 and 4. Now we can tick it. Let's see, in between negative 2 over 3 and 4, is it less than 0? Is it negative? Yes, it is. So we tick it. How about it is less than 0 for all real numbers x? Is it always less than 0? Is it less than 0 everywhere? And is it negative everywhere? Of course not. So that's wrong. It's equal to 0 when x equals 4 or x equals negative 2 over 3. Let's see, when x equals 4, is it equal to 0? Yes. How about when x equals negative 2 over 3? Yes. Okay, so that's how you do it. Question 2. Okay, I think this is now when it starts to get hard. Okay. So question 2, they give us a trinomial x squared minus 12x plus 20. Before solving, as usual, I like to factor and solve it, okay? X squared minus 12x plus 20 is going to be x, I think, minus 10, and then x minus 2. Yeah, okay, so that means I have 10, I mean 2, and I have 10. At 2, it's 0, and at 10, it's also 0. Let's see, in between our roots, it's going to be opposite to our quadratic, and our quadratic here is positive, so in between our roots, it's going to be negative. How about after the roots? It's going to be the same sign as the quadratic. Okay, now can we solve? Yes, we can solve. Okay, x squared minus 12x plus 20 is less than or equal to 0. Okay, when is it less than or equal to 0? Less than 0, it's a negative part over here in between 2 and 10, right? And it said or equal to 0, so you can also include the 2 and the 10. So when is it less than or equal to 0? When it's in between 2 and 10, right? 2 and 10. But do I put less than or equal, or do I put strictly less than? I put less than or equal because they said less than or equal here. Okay, so in between 2 and 10. Correct. Is it greater than or equal to 0 in between 2 and 10? No, we just said it's actually less than or equal to 0 in between 2 and 10. Is it less than or equal to 0 when x is before 2 and when x is after 10? Obviously not, right? So that's wrong. Okay, part D. When is it greater than or equal to 0 for x before 2 and x after 10? Let's see, before 2, is it positive? Yes, it is. And then after 10, is it positive? Yes, it is. So that's correct. Okay, is it less than or equal to 0 for okay, we already found it less than or equal to 0, so let's just skip this. And greater than or equal to 0, we just found it, so we'll skip this also. Okay, question 3. This question was wrong. Okay, the correct answer was yeah, it's that one. Okay, they're saying which one has the set of real numbers. Okay, which of the following inequalities has the set of real numbers with only one number excluded as its solution set? So basically they're saying that the solution is all of the real numbers except one number. Okay, these are wrong. Okay, actually I'll put my answer. Okay, this is the correct answer. Okay, so we want the solution to be all real numbers except one. Okay, let's take a look here. All of these, if you factor them, you're gonna get x minus 6 squared. Okay, so your solution is 6 for all of them. Okay, let's take a look at this first one here, the negative x squared plus 12x minus 36. When you only have one solution, you skip the part about it being in between two roots, because you only have one root, right? So before and after, you only would take what's before the root and what's after the root. What's before and after the root, we said it's the same sign as the quadratic, and since it's negative, it's going to be negative here, and here it's 0. How about this is for the minus x squared one. How about for the positive x squared one? Again, 6 is the same root. 6 is the root, so at 6 it's 0. But now since it's positive, it's going to be positive after, positive before. I'm talking about this one, huh? Because we have two functions here. Okay, one positive, one negative. Okay, let's take a look. When it's greater than 0. Okay, let's take a look here. When is it greater than 0? Is it ever greater than 0 here? No. So does it have any solution? Obviously not. Here, when it's greater than or equal to 0. Is it ever greater than 0? No. But is it ever equal to 0? Yes. So we could say when x equals 6, right? But they said it has the solution of the set of all real numbers with only one number excluded. In this case, the only solution is x equals 6. So here there's not only one number excluded, here there's only one number included. Okay? So obviously this will be wrong. X squared minus 12x plus 36. Now we move to the positive one. We're moving to this one here. Okay, greater than 0. Let's take a look. When is it greater than 0? It's greater than 0 after 6, so when x is greater than 6, and also before 6, so when x is less than 6. So we actually have, if you take a look here, it's always greater than 0 except for one point, right? And that is 6. So it's greater than 0 for all real numbers except 6, right? And is that what we're looking for? A set of real numbers with one number excluded, one excluded value. And in this case, that's what we have, all real numbers, and we have one excluded value. So this should be correct. But in the quiz, they gave it wrong. Part D, x squared minus 12x. Oh, what happened? Ya Allah, Ya Allah. Astaghfirullah wa atubu ilayh. I'm gonna rewrite everything. Wait. I'll cut. Okay, I wrote down what I could remember. Now part D, x squared minus 12x plus 36 less than or equal to 0. So now let's go back here. Is it ever less than 0 here? No, right? But is it ever equal to 0? Yes. So you could say there's only one solution, and it only equals 0 at 6. So only for x equals 6. Okay, but is that a set of all real numbers with one number with one excluded value? Obviously not. Okay, so we put it wrong. Now we're back to the negative one. Is it less than or equal to 0? So let's see here. Less than 0, it's less than 0 before before 6 and after 6. And when is it equal to 0? At 6. So you could say this one is all real numbers. All are. Because it's always negative after and before 6. And it could be 0 at 6. So being less than or equal to 0, every number here satisfies that condition. Okay? If it was after 6, it's negative, it would be less than 0. If it was before 6, it would be less than 0. If it was at 6, it would be equal to 0. And that satisfies all the conditions. So all real numbers. But they said all real numbers with one excluded value. So obviously that's wrong because there's no excluded value. It's all real numbers. Question 4. This is the hard one? Yeah, okay. Which one has an empty solution set? Okay, empty solution set. Whenever you have two quadratics, okay, x squared minus 10x plus 24 greater than 0, okay, and you have x squared plus 100 greater than 0 or less than 0, you have to see which one. This is, it's a system meaning the solution set of this one has to be inside the solution set of this one. Okay, so they have to fit on each other. Okay, let me make this a bit easier. So x squared minus 10x plus 24, let's factor it. If you factor it, you're going to get x minus 6, x minus 4. So if we write it in our table, we're going to have 4, we're going to have 6, we're going to have 0 and 0. In between the roots, it's going to be negative because it's opposite to the positive quadratic sign. And then before and after the roots will be positive, which is the same sign as the quadratics. Okay, how about x squared plus 100? X squared plus 100 is not factorable. Okay, x squared plus 100 is not factorable. That means it never equals 0. Okay, so this would be for this one. Okay, and then for x squared plus 100, if I were to draw it in a table, I would say it's always positive, right? Because there's no root. There's no root for it. It's always positive. Okay, so can it ever be less than 0? Let's take a look here. In this first one, x squared minus 10x plus 24 is greater than 0. Okay, one is greater than 0, one is positive, right? So it could be greater than 0 after 6, it can be greater than 0 before 4. Yeah, but it also has to fit x squared plus 100 less than 0. Let's take a look at x squared plus 100. Is it ever less than 0? No, it's always positive because it has no roots. So that's going to be wrong. But that's the one we want because they said empty solution. Yani which one doesn't have a solution? Okay, that one. How about this one here? X squared minus 10x plus 24 greater than 0. We said it can be greater than 0, it's positive, after 6 and before 4. X squared minus 100. Now let's write another one. Write another for x squared minus 100. If you factor this, you're going to get two solutions. You're going to get minus 10 and 10. Okay? So at minus 10 is 0 and at 10 is 0. Okay? And in between them, it's going to be negative. After it, it's going to be positive. And here it's going to be before it positive. Okay. So greater than 0 after 6 before 4. How about here? X squared minus 100 less than 0. When is it less than 0? In between negative 10 and 10. Right? So if I were to write this, here it would be when x is greater than 6, right? And when x is less than 4. Here it would be when x is, when is it less than 0? Between negative 10 and 10, right? So between 10 and negative 10. Okay? So do they fit on each other? Okay? X goes all the numbers after 6. All the numbers after 6. Here x can be between negative 10 and 10. So you could fit them into each other. You can, yani, what I'm trying to say is, yani, they fit on each other. If I were to draw this on a number line, okay, this would be a number line. I would have 4 here, I would have 6 here. Okay, I want all numbers, all numbers after 6, right? And then I want all numbers before 4. Okay, then here in between negative 10 and 10. So I would have negative 10 over here, okay, and I would have 10 over here. Okay, I would draw a line in between them. Does it fit our solution set? Yes, it does. We have some intersecting parts, right? This is just, I'm trying to explain it in the best way I can. And other than this, I don't know how to explain. Okay, part C. Okay, same thing. This is the same solutions. Okay, x greater than 6, x less than 4. So they're asking the same question. But this part, x squared plus 1, it can't be factorable. X squared plus 1. Okay, so since it has no roots, it's always positive, right? So in the question they're saying less than 0. Can it be less than 0? Obviously not. It's always positive. How about here? Okay, here they said same thing, but now they said x squared plus 100 is greater than 0. So now it's actually positive. And when is it positive? For all real numbers, right? All real numbers. And here we said x greater than 6, x less than 4. So do they intersect? Obviously, if it's all real numbers, then they intersect. Okay, so this would be correct. It would have a solution, but that's not what they're asking here. They want the empty solution. Okay, so you don't take this. It's wrong. Okay, this here would be correct. Question 5. And I'm sorry, yani, these questions, they're a bit annoying. I can't do anything for you, really, and I'm just doing my best at explaining. Which two have a solution set equal to this? Okay, we actually just solved this, right? We said that the solution set of this greater than 0 is when x is greater than 6 and when x is less than 4, right? So which one has a solution set equal to it? Okay, solution set equal doesn't necessarily mean yani, it has the same solution. Or wait, no, actually it does. Okay, yani, it means, they intersect. Okay, so let's see here. X squared plus 1 less than 0. Does it have a solution? There's no solution, right? Because we said x squared plus 1 is always positive. How about here? X squared plus 100 greater than 0, right? It's greater than 100 always, right? Real numbers. Because x squared plus 100 always greater than 0, right? So this one would be correct. So would it be intersecting at the x greater than 6 and x less than 4? Obviously, because it's all real numbers. So it would have an equal set. So this system would be true. How about here? X squared minus 100 less than 0. Okay, this is different because this one's actually factorable. Okay, we said this is x greater than 6, x less than 4. X squared minus 100 less than 0, if you were to write it, x squared minus 100, you get two solutions, negative 10 و 10. هون 0 هون 0, in between then negative, بعدهم positive. Okay, when x squared minus 10x plus 24 is greater than 0, it's in between, it's after 6 and less than 4. So if I were to write this here, I'll put the 4 here and the 6 here, right? The 6, actually, let me move it a bit closer just so I can help you to visualize it. So I'll put the 4 up here and the 6 here. And in between these two are negative, right? So we said after the 6. So let's start from 6. After that, it starts to become greater than 0. Okay, if you start from 6 on the other equation, it's negative here. So will that work? It won't work, if you get what I'm trying to say. So they have to work, it has to work on both equations. Okay, so would 6 be a solution to the other equation? No, it wouldn't, because here if you go from 6 in the other equation, it's gonna be negative. Okay, so you have to find a number that fits both solutions. That's why it's a system, because it has to fit both. So 6 here wouldn't fit the other one, because here it's negative. At 6 it's negative. So if you were to continue, it would be positive in the first one, but in the second one here it would be negative, so it wouldn't work. So that's why this one is wrong. X squared minus 10x plus 24 greater than 0, same thing. We said x greater than 6, x less than 4, same solutions. X squared plus 1 greater than 0, remember we said it's true because it's real numbers, because we said x squared plus 1 always greater than 0. Okay, so obviously if it's all real numbers, if the solution is all real numbers, then it's obviously going to fit with x less than 4 and x greater than 6. Question 6. Move down a bit. Can I not zoom out? Zoom. No zoom. Top. How do I like this? Okay. Okay, question 6. Solution set of x squared. So they gave you it. So they gave you x squared minus 12x plus 20 greater than 0. When is it greater than 0? They gave you it dashed in black. So it's positive here and it's positive here. Easy. And then for x squared minus 13x plus 36 greater than 0, it's after 9, 4, 4. So obviously our roots are 2, 10, 4, 9. Okay, so which of the following systems has an empty solution set? Okay, when this is positive, this is positive. Is that empty? Let's see. So when this is positive over here, it's after 10, and when it's positive, it's also before 2. So after 10, 10 would be here. Okay, would that also work here? Would that be positive here in this solution? Yes, it would be. Okay, how about before 2? Yes, it would be. So this is correct. Okay, less than 0, less than 0. Okay, when is this less than 0? When is it negative? It's in between 2 and 10, right? So in between 2 hold up. Yeah. So you could say in between, 2 is over here. So here's 2, here's 10, right? Akid, it won't be less than 0 for all of them, right? But it would be less than 0 for this part only. So you could say in between 4 and 9. So it would still have a solution. And if you take this, they would still intersect in this part, right? The 4 and 9 part. They would intersect at that part. You could say they intersect between 4 and 9. Okay, that's how I'm gonna write it for you. Okay, how about when this is less than 0, this is greater than 0. Okay, this is less than 0 in between 2 and 10. Okay, when is it greater than 0? After 9, before 4. Okay, so do they intersect? You'd have this small part over here intersecting, right? The 2, from the 2 to the 4 intersecting. And we also have the small part of the 9 and 10 intersecting. Intersects between 2 and 4 and 9 and 10. Okay, this 2 here is when it's less than 0, right? Between 2 and 10. Okay, so if you look at the two graphs, this would intersect. There would be a small part of it here in between the 2 and the 4. It would work, and it would work. And between the 9 and 10, it would work. How about this one here? X squared minus 12x plus 20 greater than 0. So this one went positive, so after 10, before 2. X squared minus 13x plus 36 less than 0. Okay, now is when خلاص, there's no more solution. Greater than 0, it would be خلاص, after 10, before 2. But less than 0 here would be between 4 and 9. So I'm saying after 10. I skipped, there's no intersection. I skipped, okay? Here it's only between 4 and 9. But here I'm at 10 now. I'm at 10, I'm going to the right. So I skipped. How about also the 2, right? At 2, everything before 2. But it starts at 4, so I started at 2. Is there any intersection? No, there isn't any intersection. The 4 9's over here, but the 2 is going to the left, and the 10 is going to the right. So there's no intersection. No intersection. Okay. X squared minus 12x plus 20 less than 0. X squared minus 13x less than or equal to 0. Okay, less than or equal to 0. Do they intersect? Of course they intersect. Here, this negative part, does it intersect this negative part? Yes. From 2 to 10. So 2 to 10. Does it intersect this part here, 4 and 9? Yes, it does. Okay. That's an easier way. Just draw it and see if they intersect. Draw the line. Look at it. Here, between 4 and 9 is what I want. Do they intersect? Yes, they intersect between 4 and 9. So there is an intersection. Okay. Oh, let me erase this. It's going to be too messy for the PDF. Put 2. I'm going to put 10. Okay. Question 7. Okay, this is very easy. Basically, they're saying, what are the roots? And you solve it. So x squared equals minus 4. So x will be the square root of negative 4. And obviously, there's no square root of negative numbers. But what you would do is, if you ever have a square root of any number, any negative number, express it as the positive number times negative 1. Okay? So x equals the square root of 4 times negative 1. Okay, and the square root of 4 is 2. So x will be 2 root negative 1, right? x1, x2, there's 2, it's plus minus, right? Because any square root is always plus minus. Okay, the square root of negative 1, you all know it's I. So you're going to get, the first root is 2 times I, and then the second root is negative 2 times I, because plus minus, yeah? Plus minus. So 2i and negative 2i. Question 8. Which of the following is the solution of inequality? Okay, this is now when the questions start to get a bit easier. All you have to do is solve. Okay, the first thing you do when solve is make sure when you're solving with absolute value, everything make sure that you keep the absolute value alone. Okay, so here I want to keep the absolute value alone. Let's rewrite it. 1 minus absolute value of minus 5z greater than or equal to minus 9. Let's take the one to the other side. You're going to get minus absolute value minus 5z greater than or equal to minus 10. Now we have to divide by this negative. So it's going to come absolute value minus 5z less than or equal 10. You know, when you divide by a negative, when you're working with greater than and less than and stuff, it changes the sign. Okay, now I just have to solve this. When working with absolute value, there's two equations you write. You write the original equation, okay? You just write it normally. Absolute value of minus 5z. Wait. Yeah, the first equation would just you be writing it normally. What's the absolute value of minus 5z? It would be 5z, because you know absolute value makes things positive. Okay, you just write it normally, and you solve it. You get z is less than or equal to 2. The second equation you write, however, okay, you take down the absolute value. It becomes positive, right? But the second equation you write has to be flipped. Okay, the second part has to be flipped. So this less than or equal will become greater than or equal, and this 10 will become negative 10. Okay, you have to flip the other side. And then it solves, you get z greater than or equal negative 2. So it's greater than or equal to negative 2, but it's less than 2. So it's going to be in between both of them, right? It's going to be in between negative 2 and 2, right? There you go. Question 9. Okay, I think, yeah, this is where it becomes way easier. Okay, a solution to, they gave you 3y greater than 35. They gave you 4x plus 3y less than 25. Okay, so they gave you, the solution is x, comma 12. Okay, we want the largest possible integer value of x. So what did they give us? They gave us y is 12, right? So let's plug that in here. 4x plus 3y. And we know y is 12, so 3 times 12 less than 25. So you get 4x plus 36 less than 25. You get 4x less than minus 11. X is less than minus 11 over 4. Okay, minus 11 over 4 is, as a decimal, is less than minus 2.75. So what is the largest possible integer after negative 2.75? That would be negative 3. Okay, that's the largest possible. You could say negative 4, you could say negative 5, but you want the largest possible one. Okay, so it could be negative 3. Question 10. Okay, this is very easy. Sam has 25 dimes. Okay, a dime is 0.1, by the way. $0.1. Okay, and n quarters, you know, quarters are $0.25. Okay, in his piggy bank, write an equality that is describes the possible value of n given that he has more than $5.5. Okay, 25 dimes. That means 25 times 0.1. And he has n quarters, so we could just say 0.25 n, because each quarter is 0.25. And they said that he has more than 5.5, so greater than 5.5. Now you just solve this. 25 times 0.1, 2.5 plus 0.25n greater than 5.5. This becomes 0.25n greater than 3 because you just subtract by 2.5. This becomes n is greater than 12. That's it. Put it here. Question 11. Okay, there's a lot of text, but it all makes sense. Don't worry. A company packs its production in small boxes. Okay, small boxes that weigh 15 kilos, and then large boxes that weigh 30. Each are shipped in containers. Each container can hold a maximum of 100 combined boxes, with the total mass of that container not to exceed 1,800. Let x be the number of small boxes and y the number of large boxes. What are the system of inequalities? Okay, so if x is the small, okay, y is the large. We know the first condition that it can hold a maximum of 100 combined boxes. So however you add the boxes, it should be less than or equal to 100. So that means x plus y will be less than or equal to 100. So that's our first condition. They said the weight cannot be 1,800. What's the weight of each small box? 15. So we could say 15 times each small box x, right? Plus 30 times each large box y. Okay, it has to be less than or equal to 1,800. So these are my two conditions, this and this. Question 12. Okay, I'm gonna give you the rule for i's. Okay, I to the power of 1 is obviously the square root of negative 1, right? It's just I. I to the power of 2 is negative 1. I to the power of 3 is negative I. I to the power of 4 is, I think it should be I, positive I. Is it positive I? Wait. No, sorry. It's just 1. It's positive 1. Okay, how this works is, yani, I is negative 1, a square root of negative 1. Okay, multiply square root of negative 1 by square root of negative 1 again, you get negative 1. Okay, then negative 1 times I again, you get negative I. Okay, then negative I times I again is negative I squared. And you know I squared is negative 1. So negative 1, which is positive 1. Okay, المهم, this is a table you have to know. Okay, 1, 2, 3, 4. What does this have to do with anything? Look, whenever you have powers of I, you just divide it by 4. The rule of it is divide by 4. And check your remainder. 12 divided by 4 is 3, remainder 0. Okay? Since there's no remainder, I take to the power of 4. Okay? So that means I to the power of 12 equals 1. Okay, how about I to the power of 7? I to the power of 7, you do 7 divided by 4, you get 1, remainder 3. So that means I to the power of 7 equals negative I, because you take the 1 for 3. Since the remainder was 3, you take the 1 for 3. Okay, so now I have to subtract these. So I have to take 1 minus this negative I. okay, which is 1 plus I. Question 13. Okay, this is very easy. Minus x squared plus 7x plus 18. Factor it. Obviously, the first thing you do is remove the negative. So it will be x squared minus 7x minus 18 less than 0. Because you remove the negative, you have to switch signs. If you factor this, you're going to get x minus 4. No. You're going to get, sorry, x minus 9, x minus 2. Sorry, x plus 9. Wait. Was it x plus 9? No, it's x minus 9, x plus 2 if you factor. I forgot how to factor, I don't know why. المهم, that means our roots are negative 2 and 9. So at negative 2 it's 0 and at 9 it's 0. In between our two roots it's gonna be positive y. You look at our original quadratic, it was negative, and in between the two roots it's always opposite to what your quadratic is. Then after it, it's the same. So after it's going to be negative, before it's going to be negative. Okay, let's see here. They want greater than 0. So when is it positive? When is it positive? It's positive in between negative 2 and in between 9. That's it. Question 14. Okay, solve the inequality x squared plus 8x plus 16 greater than or equal to 0. Okay, if you factor this, you're going to get x plus 4 squared greater than or equal to 0. So you have only one solution, okay? And that root is negative 4, right? So at negative 4, it's going to be 0, and after it, it's going to be positive, and before it, it's going to be positive. Okay, so let's solve it. When is it greater than or equal to 0? So when is it positive? It's positive before negative 4 and after negative 4. But they also said greater than or equal to 0. Is it equal to 0? It's equal to 0 at negative 4. Okay, is there any other number here? No, right? So the solution set for this is all real numbers, since it's always either positive or it's 0. And they said if it's all real numbers, then put 999. So the answer is 999. So question 15. Okay, solve the inequality x squared plus 3x plus 4 greater than, less than 0. X squared plus 3x plus 4 less than 0. If you try factoring this, the first thing obviously you do b squared minus 4ac, right? The quadratic formula. You're gonna get it's less than 0. Okay, it's negative. I'm not gonna do it. Actually, no, I'm gonna do it. Just to prove yani, so you guys can better understand. B squared would be 3 squared minus 4 times 1 times 4. Okay, which is radical 9 minus 16, so radical minus 7. And since the discriminant is negative, that means no solution. Okay, and if there's no solution, empty solution set, you put 1, 1, 1. Okay, if you want to factor it on your calculator, which please, if you don't have a calculator that can factor, buy one. They're very useful. Okay, if you factor it, you're going to get I in your answer. That just proves there's no solution. And question 16. Okay, x squared plus 2x plus 7. Okay, factor it greater than or equal to 0. Okay, x squared plus 2x plus 7. This time, this one also, if you factor it, there's no solution. Okay, but that doesn't mean there's no solution set. Look what happens. If you were to write it as a table, obviously we would have no roots, right? So we just put nothing, right? And since it's no roots, the quadratic is always positive, right? It's positive everywhere. So when is it greater than 0? In this case, since there's no roots and it's always positive, it's always greater than 0. So it's the set of real numbers. So you put 999. So Walid, what happened to the last question? Okay, let me go back to the last question. They said less than 0. Okay, this one, okay, it might have no solution, right? So no solution, and it's always positive, right? Before and after, always positive, because it's positive quadratic, since there's no roots. Okay, if it's always positive, when is it going to be less than 0, Habibi? It won't. So that's why there's no solution set. Okay, that's why it's empty solution set. Question 17. Question 17. Okay, this one, you just expand minus 3 times 5 minus 15 minus 3 times minus 9i is plus 27i, plus 2i times 5 is plus 10i, and then plus 2i minus 9i is minus 18i squared. Okay, I squared we said is negative 1, right? So minus 18 times negative 1. Okay, هون كان في 10i وهون في 27i هون minus 15. Okay, you can simplify this. Minus 15 plus 18, minus 18 times minus 1 is plus 18. So minus 15 plus 18 is 3. Then 27 plus 10i is 37i. So 3 plus 37i. That's it. Thank you so much for watching. Sorry it was a long recording, but I can't do anything. Good luck.